Greetings, math fans. All right, so this is day 3 of radicals. Okay, and basically what we're doing today is we're going to do some multiplication, and we're also going to do some simplifying where the radicals are not perfect squares or perfect cubes. Okay, so real quickly, this is just some basic multiplying. If I give you, the square root of 3 times the square root of 5. It's really easy as long as these are the same, which of course these are the square root. It's a 2. You can just multiply these together. So it's really the square root of then 3 times 5 or the square root of 15. Okay, super easy. So again, if I have the fourth root of 6 times the fourth root of 5, I can get the fourth root of 30. That's pretty easy, right? Okay. If they're not the same, you can't multiply them. You're not really going to get any of those, but understand that if they're not the same, we call that a radical, right? If they're not the same root, then you cannot multiply them together. But most of the ones we're going to have, you can. So I'm not trying to trick you guys. Okay? So pretty easy stuff. So let's just talk a little bit about simplifying now, because and if something is not a perfect square, because it's a little tricky. But once you get it, it's really not bad. So let's start out with like a really basic problem here. If I ask you to simplify the square root of 8. So here's the deal. So there's a 2 here, okay? And what I'm doing is I'm looking for perfect squares. So I'm going to show you 2 different ways to do this. All right? I'm looking for perfect squares that go into 8. So in other words, what you would tell me, you would say, Mr. Curvis, it's 2 times 4. Because I know 4 is a perfect square. And I'm like, okay, good. So here's the deal. Once you find perfect squares, you can pull those out. I can take the square root of 4, which is, so the square root of 4 is 2. That means this would come on the outside, and I would say 2. So the answer, then that would be out of the inside. So the answer to this one is 2 times the square root of 2. Okay? Because again, that 4 was a perfect square, so I was able to pull it out underneath from underneath the radical and put it on the outside, but I don't forget to take the square root of it. Okay? So give you another example here. If I said the square root of 18. So you're trying to think of numbers that go into 18 that are perfect squares. So again, you should know the perfect squares. If you don't, have them written down. So 4 and 9, right? 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 36, etc., right? They should kind of be in your brain a little bit. If not, you should have them written down someplace. At least you can kind of glance over at them. So 18 you should recognize as 2 times 9, because 9 is a perfect square. Okay? And then the square root of 9 is 3, right? The square root of 9 is 3. So this comes on the outside, and then whatever's left over that you can't simplify anymore, you can't take the square root, that's left on the inside. And so this is my answer, 3 square root of 2. All right? A great way to check it is put it in your calculator. This what I just did here, this means 3 times the square root of 2. Okay? So you can put that in your calculator, and I'm going to do it, actually, you can't see me doing it, but I'm going to type in 3 times the square root of 2, and I get 4.24. And then I'm going to type in the square root of 18, square root of 18, and I get 4.24. It's just a good way to check it to see if you actually did it right. Square root of 18 versus 3 square root of 2. Of course, they're both the same, 4.24. Okay? It's a good way to check it. So let's do a couple more, but I'm going to show you a different way to do it in a second here, because I think this is okay, but there's another way to do it as well. Okay? And again, I'm trying to show you a couple different ways because some people learn a little bit better doing different methods here. So if I do like the square root of 27. So you should say, 9 times 3. Oh, square root of 9 is 3. 3 comes on the outside, and there's a 3 left over. Okay? It's not bad, right? So I'm going to show you variables in a little bit, but I want to stick with numbers just for now. We've done variables I think almost in day 1, but I'll show it to you in a little bit here. But that's looking for perfect squares. Now here's where it changes up a little bit. Okay, if I do, instead of perfect squares, what about a cube? So if I said, let's do 24, the cube root of 24. I'm looking for perfect cubes, and a perfect cube is an 8. 2 cubed is 8. 3 cubed is 27. Well, it certainly can't be any bigger than 20. I mean, 27 is already too big. Okay, so the cube root of 8 is 2. So watch this. Do you guys agree that it's 24 is 3 times 8? Okay, and what's the cube root of 8? The cube root of 8 is 2. And what do you have left over? A 3. So this is my answer for this problem. Okay, it's a little trickier. Okay, but I'm looking for perfect cube roots when I have a 3 here, as opposed to the other ones I'm looking for a perfect square root when I have 2. Now I know this gets to be a little overwhelming, so I'm going to show you kind of a cool way to do all these problems. Okay, you got to use your calculator because you're looking for pairs of numbers, 3 of a kind, 4 of a kind, etc. So just kind of bear with me. I've been doing this a while and it seems to work out pretty well. Okay, so let's go back to the square root of 8. There's a 2 here, even though I don't usually write the 2 here. A perfect square, which is 4, is 2 times 2. So it's really a pair of 2's. Just like 9 is a perfect square, that's 3 times 3. That's a pair of 3's. And let's, if I said like 25. 25 is 5 times 5. That's a pair of 5's. Okay, so what I'm doing is I'm looking for pairs of numbers, and then I can pull it out. So this is what I'm going to do. On my calculator, I'm going to take 8, and I'm just going to start dividing it. I'm going to write this in bold red here. You're going to divide numbers by 2, by 3, by 5, and by 7 in general. You can go higher than that, but these are all called prime numbers. Okay, in other words, you can't break up a 2 anymore, except 2 times 1, but you can't break it up. Like 6, you can say 6 times or 3 times 2. Okay, or 8, you can say 2 times 4. Okay, but 2 you can't break it up, 3 you can't break it up, 5 you can't break it up, and 7 you can't break it up. 4 and 6 and 8 and 9, 10 you can break up. 11 you can't either, but that's kind of getting big. All right, so you have 2, 3, 5, and 7. Here's the deal. I'm going to start taking that 8, I'm going to start dividing it by number. So bear with me here, okay? It takes a little bit, but I know kids like it. I've been doing this for several years, and after I do it for a couple days, kids start getting used to it, and they like this. All right, that 8, I'm going to say 8 divided by 2. Now, how do I know 2 goes into it? Well, it's an even number. Okay, so 8 divided by 2 is 4. So I can write 8 as 4 times 2. And then I want to keep breaking it up. So 2 is here. I can't break that up anymore. So let's go with 4. Let's break up 4. Well, 4 is 2 times 2 times 2. All right? So 8 is broken up into its smallest possible numbers. And now we're almost done. I'm looking for, since this is a 2 here, guys, I'm looking for pairs of 2's. Because remember, a pair of 2's is 4, right? 2 times 2. A pair of 2's is 4. Okay? So what I'm going to do is I'm going to take, so let me just do a couple of these problems. I'm going to take a pair of 2's out and bring it to the outside. And when I bring a pair out, it becomes 1, 2, because I'm taking the square root of 4, which is 2. And what do I have left over? 2 on the inside. Okay? All right, this looks a little confusing, but it's not that bad. So I got a bunch more problems, but just bear with me. If you bear with me, you get it. If you go, I'm shutting this video off, there is no way I'm going to get this, then you're not going to get it. All right? So bear with me. All right. So let's try another pretty simple problem here. Let's do the square root of 12. So again, I'm going to write this in red because I think it's important. It's 2, 3, 5, and 7. Those are the numbers I'm going to divide it by. All right, if I can. So 12, I can certainly, again, if it's even, you better be dividing it by 2. And you're working your way up, by the way. You're doing 2 first, then 3, then 5, and then 7. Now, it's easy to recognize if something is divisible by 5. You know, if I said like 315, I know it's divisible by 5, so I'm going to divide it by 5 right away. Why not? Okay? All right, so square root of 12, I'm going to divide that by 2. 6 times 2. Okay, 6, I'm going to divide that by 2. Use your calculators. I don't care. 6 divided by 2 is 3, so it's 2 times 3 times 2. 12 is now broken up into the smallest possible numbers, so my answer to this problem, I can take a 2 out and a 2 out. One pair of 2's, which means a 2 is on the outside, and what's left over on the inside is a 3. So my answer is 2 root 3. We did it before by saying, looking for perfect squares, and I was looking for, well, 12 is 4 times 3, square root of 4 is 2, and you have a 3 left over. And that's okay, you get the same answer, but I really think I like this way. This is kind of nice to do it this way. Just because you can do even nastier problems, okay? It's where you don't know the perfect squares. All right, so let's keep going here. How about the square root of, let's do that 24. We did it before. Square root of 24. Well, I'm going to write these out here. 2, 3, 5, and 7. Okay, square root of 24 is divided by 2 is 12 times 2. Okay, I can divide 12 by 2, so 6 times 2 times 2, and divide that 6 by 2, 3 times 2 times 2 times 2. Okay, so my answer is there's only one pair of 2's here. That's all I can take out, one pair of 2's. The rest of it I don't have a pair. So my answer is a 2 on the outside, and what's left over? 3 times 2 is 6, so it's 2 root 6. What? It's not bad, is it? Okay, let me do a tougher one, which I think it's just kind of good for you to see a tougher one. How about, let's see, square root of 160. If you came up to me in the middle of the hall and said, Mr. Curvis, what's square root of 160? I'd be like, I don't know. Okay, but you give me about 15 seconds, I can tell you what the square root of 160 is. The first thing I'm going to do is I'm going to divide it by 2. You can divide it by 5 if you want, because I know 5 goes into 160 because of that 0 there. Okay, but I'm just going to divide it by 2. So 80 times 2. I'm going to divide that 80 by 2 because I can, right? So 80, that's 40 times 2 times 2. All right, I can divide that 40 by 2. So it's 20 times 2 times 2 times 2. See what I'm doing here? Divide the 20 by 2. So 10 times, that's 4 of these. And the 10 is 5, so I got to go up here and do it. So it's 5 times 2, and then you got 4 more 2's. Oh, wow, okay. That's a lot of 2's. So again, I'm looking for pairs. So here's a pair, and here's a pair. I don't have anything else, no pairs. It's just a 5 and 2 here. So I pull a 2 out. I pull another 2 out. So I really get 2 times 2 on the outside. And the inside, I get 5 times 2 left over. So I multiply everything together. I get 4 root 10. And that's my answer. That was tough. If you didn't know what you're doing, that would be tough. But if you know what you're doing, it's like super easy. Just dividing by 2, 3, 5, and 7. That gives you your answer. Okay? All right, let's do a couple more. Okay, let's delete all this here. All right, let's do how about square root of 162? Well, I'm going to divide by 2 first because it's an even number. So again, using your calculator, 2 times 81. Now here's the deal. If you recognize 81 is a perfect square, the square root of 81 is 9. You are done with the problem. Pull it out. So it's 9 root 2. If you didn't know that, this is what you do. 2 times 81. You'd go, oh, 81. Okay, well, I know 2 can't go into it anymore because it's not an even number. So 81 divided by 3. Let's try it out. 81 divided by 3. Oh, it's 27. Okay, so 2 times 3 times 27. Okay, so let's keep dividing it. Again, let me write these numbers out here. 2, 3, 5, and 7. All right, so let's divide it by, again, once 2's out of the picture, cross it off because you'll never be able to divide it by 2 again. So let's keep going with 3. 27 divided by 3. Oh, it's 9. Okay. Oh, I'm using big, bold red here. Let me get rid of that. Big, bold red. 2 times 3, and then 9 is 3 times 9. Cool. Okay, let's, oh, well, 9. Well, 9 is 2 times 3 times 3, and then 9 is 3 times 3. All right, so that's it. 2s, 3s, 5s, and 7s. Can't do any more. This is just in terms of 2s and 3s. So let's look for our pairs. I got a pair of 3s, and I got a pair of 3s. Hey, cool. So I bring them out. So I got a 3 and a 3, and then 2 left over. So 3 times 3 is 9, and a 2 left over. I'm done with the problem. 9 root 2. Okay? Not bad. Let me do just a couple more. I know some of you guys are going, come on, Mr. Curvis, get done with this lesson. You can always skip forward a little bit, but I think it's good practice. I got a few more things to show you guys anyway. All right? So let's do a crazy one. Okay, I mean, this is ridiculous. Nobody can do this in their head. Square root of 5400. So this is what I'm going to do. I'm going to start dividing by 2. All right. So if and I have my calculator next to me. I'm using my calculator. So divided by 2, 2700. So 2 times 2700. Okay. I'm going to divide that by 2 again. 1350. So 2 times 2 times 1350. I can keep going. 2 times 2 times 1350 divided by 2. 675. Okay, I know I can't do 2 anymore, so I'm going to try, I can do 5, but I'm going to do 3. I'm just going to work my way up. I like 3, it's good. So 2, 3, 5, and 7. Work my way up. Well, 675 divided by 3. Hey, good, it works. Okay, so I'm going to get 2 times 2 times 2 times 3 times 225. Okay, I'm going to divide that 225 by 3. Oh, good, 75. Okay, so 2 times 2 times 2 times 3 times 3 times 75. Okay, I'm going to divide 75 by 3. Oh, perfect, 25. Okay, so it's 2 times 2 times 2 times 3 times 3 times 3 times 25. And then I can't divide 25 by 3. I tried it and it doesn't work, right? I know that. But I know, what is 25? 5 times 5. Okay, cool. So 2 times 2 times 2 times 3 times 3 times 3 times 5 times 5. Brutal! Brutal! Okay, we're done. We split 5400 up to as much as possible. Okay, let's look for pairs. Got a pair of 2s, pair of 3s, and a pair of 5s. Okay, so on the outside, you're going to have 2 times 3 times 5, and what's left over on the inside? 2 times 3, which is 6. So let's multiply this out. 2 times 3 is 6. 6 times 5 is 30. So my answer to this nasty old problem is 30 root 6. It took me about a minute and a half maybe to do this problem. 30 root 6. If I type this in my calculator, 5400, the square root of 5400, I get 73.48. 73.48. If I type in 30 root 6, so 30 times root 6, what? 73.48. I get the same thing. Okay? So did some nasty, this is the nastiest problem I could possibly do. So let's do a problem where it's not just a square root. All right, so I don't mean to be dragging this out here, but I think it's important to just to talk about this. If I'm doing like the, let's say the cube root of 16. Remember I told you about pairs? You're trying to get pairs? Guys, there's a 3 here. So you're looking 3 of a kind, 3 of one number. That's what you're looking for. Before I was looking for pairs, now I'm looking for 3 of the same thing. So watch this. We're going to do the exact same thing. I'm not doing anything different. 2, 3, 5, and 7. So 16 divided by 2 is 8. So 8 times 2, and this is cube root each time. 8 is 4 times 2 times 2 then. And then 4 is 2 times 2 times 2 times 2. Okay? You're looking for 3 of the same number. So here it is, 3 of the same number. So my final answer for this one, right, I'm going to take this 2 out. So I got 2 on the outside, and I have a 2 left over. So the cube root of 16 is 2 times the cubed root of 2. So don't panic when you have a different number here, but understand you're looking for 3 of a kind. Okay? If I gave you, let's just go a little crazier. Let's do the fourth root. The fourth root of 162. Okay, start splitting it up. Let me write these on the board. 2, 3, 5, and 7. Okay, so 162 is 81. All right, let me just say 2 times 81. I just divided it out. 2 times 81. And 81, well, I can't divide by 2 anymore, so I can divide by 3. So I get 3, and this is the fourth root. Let me keep writing that here. So it's 3 times 27. 2 times 3, 2 times 3, and then 27 is 3 times 9. And the last one is the fourth root of 2 times 3 times 3, and then 9 is 3 times 3. Oh, sweet. 4 3s. That comes out. So you have 3, and the leftover is the fourth root of 2. And that's your answer to that problem. Okay? That's not bad, right? It was pretty easy to do that. Yeah. So that's how you do some pretty nasty problems here. Okay, let's just talk about variables real quickly. We already talked about these, but I think it's important to talk about variables. If I have the square root of, so I'm going to put a 2 here, even though it's usually not there. The square root of y to the 6th times z to the 7th. Remember what I told you to do? You're basically saying 6 divided by 2. So 6 divided by 2 is 3. So you're going to get y cubed, because you're always taking these numbers. So it's y cubed, and there's nothing left over. It goes in evenly. This z to the 7th, you can't divide it by 2. So what's the biggest number you can take out? Well, do you guys agree 2 goes into 6 evenly? So that means I can say, I can rewrite this z to the 7th as, let me cross it off, I can say z to the 6th times z to the 1st. Because then when I take the square root of z to the 6th, I get z cubed, and what do I have left over? Z to the 1st. So that's my answer. Okay, y cubed, z cubed, z to the times the square root of z to the 1st. Okay? So let me do another one here, a little crazier. What if I said, the cube root of a to the 7th, b to the 8th, c to the 9th. Okay, I would write, I know I need to get numbers that 3 goes into, so I have 7 here. Well, what's the biggest number it goes into? Do you guys agree it's 6? So can I do this? A to the 6th, and what's left over? So it's a to the 1, right? Because 6 plus 1 is 7. And 8, 3 doesn't go into 8, but it's, again, so it's b to the 6th times b squared, because again, 6 plus 2 is 8. And 9 is good, so I'm just going to leave this c to the 9th. That's perfect. All right, so I'm going to worry only about this guy, and this guy, and this guy. These two, stay inside the parentheses. Okay? Or underneath the radical, I should say. So you're going to say a to the 6th, the cube root of that. You're going to say a squared, because 6 divided by 2 is 3. 6 divided by 3 is 2. Let me put the leftovers. The leftovers are a to the 1st. And let's do the b now. Again, it's 6 divided by 3 is 2, so it's b squared. And there's a b squared left over as well right here, so b squared. And c to the ninth, so 9 divided by 3 is 3. So c cubed, and there's nothing left over. And let me put a cubed root. So this is my final answer. All right. So again, you're always looking to see what number goes into it, right? If I have the fifth root of something, these need to be multiples of 5. So it needs to be a to the 10th or a to the 20th or a to the 30th. If it's like b to the 17th, well, you're going to say, well, that's b to the 15th and b to the 2nd. 15 plus 2 is 17, and that's what you're starting with, but you need the 15th. So the fifth root of b to the 15th is b cubed, right? 15 divided by 5 is 3. Okay? So let me do one with everything in it, because I think you need to see one of these. And then last thing we're going to do is multiplication. This is kind of a long lesson. I already see it's like 25 minutes, but you know what? It's got a lot of stuff in it, and I'll tell you, this is pretty critical stuff for radicals and knowing this for the Harper test. You got to know this stuff, okay? So real quickly, if I did the cube root, let me come up with a good one here. The cube root of 108, x to the 11th, y to the 12th, z to the 13th. That's a good problem. So the first, let's deal with the 108 first. I'm going to write these numbers out here: 2, 3, 5, and 7. Okay. So let's start splitting it up. 108. I'm using my calculator. 108 divided by 2. So 2 times 54. Okay, I can keep dividing up by 2. So 54 divided by 2 is 27. So 2 times 2 times 27. Okay, so I'm going to write, split up. Well, I know I can't divide by 2, so I'm going to start going with 3 now. So 27 divided by 3, 9. So 2 times 2 times 3 times 9. And then 9 splits up to 3 and 3. So 2 times 2 times 3 times 3 times 3. Okay, so what do you got here, guys? 3 3s. So you pull that out, and you got 3. And what's left over? 2 times 2 is 4. Okay, cool. So 3 times the cube root of 4. Nice. Okay, let's deal with our variables now. Do you guys agree that x to the 11th, what number goes into up to 11? Do you guys agree it's 9? So let me write this out. I'll write it in blue here. It's x to the 9th times x squared. Okay, that gives you 11. And y to the 12th, that's perfect, because 12 divided by 3 isn't even, it's a whole number. So I'm going to leave it as y to the 12th here. And z to the 13th, well, what's the biggest number that 3 goes into if you multiply it? Well, it's 12. So it's z to the 12th and then z to the 1st. Those are what you're going to deal with. So here's the deal. These are the numbers you're actually going to take the square root of, or in this case, the cube root of. And the ones in green that I'm circling, that's your leftovers. That's under the radical leftover. Okay, so let me write out the final answer here. It's 3, it's from here, right? 3. The cube root of x to the 9th, 9 divided by 3 is 3, so x to the 3rd. Y to the 12th, 12 divided by 3 is 4, so y to the 4th. And 12 divided by 3 is 4, so z to the 4th. Okay, and then here are the leftovers. Well, we already said 4 from this problem. X squared right here, and z to the 1. So this is it. Nasty little problem, but that's it. That's all numbers and variables. Nastiest problem I could possibly give you. Okay, and that's what you do. All right, let me finish this up. I'm just going to do a couple more minutes, because the last thing, remember how we started with multiplication at the beginning? So I want to show you what happens if I do multiplication like this. So let's do a problem here. If I said the square root of 3 times the square root of, let's do 12. You could multiply these together. I could say the square root of 36, and that's cool. In fact, the square root of 36 is 6. But sometimes multiplying these together is not always a smart thing to do. And the only reason I say that, guys, is because sometimes you got to pull it apart. Like, well, in fact, most of the time you have to pull it apart. You got to break it up. Well, why would you multiply it together just to have to divide it out later? So let me give you a better example here. If I said the square root of 5 times the square root of 10, why would you say square root of 50 and then start dividing it out? Why not go, oh, 5 is, let's write it out as one square root like this. Put it together and go, oh, 5 is already broken up. And I'm going to write my numbers out here again. 2, 3, 5, and 7. So 5 is already broken up, so why don't I just do this? Well, 5, what's 10? Well, 10 divided by 2 is 5. Oh, okay, cool. Here's a pair of 5s. So 5 root 2 is my answer. Okay, as opposed to saying square root of 50, and now I got to start splitting it up. Why not just do it ahead of time and get 5 root 2, and you're kind of good to go. Okay, so here, let me give you another really good example. If I said the square root of 28, this is kind of a big, that's all right. Square root of 28 times the square root of 21. I mean, if you multiply those together, that is ridiculous. Because first of all, can you see a number that goes into 28 and 21? And maybe you don't. And if you don't, that's fine. But I still wouldn't split it up. I see 7 goes into both of these. Okay? But let's say you didn't even see that. I'm just going to do this. 28 times 21. Put under one radical and just start splitting it up separately. 28 is, if I divide that by 2, 14 times 2. Let's do the 21. Well, 2 doesn't go into it, 3 does. So 7 times 3. All right, let me write these numbers out again. 2, 3, 5, and 7. Okay, well, so that's good. That's good. 14 still needs to be split up a little bit. So 7 times 2 times 2 times 7 times 3. All right, we're good to go, man. There's nothing else I can pull apart here. Right? 7s and 2s and 3s. So if you notice, I have a pair of 7s and I have a pair of 2s. So that comes out, 7 comes out, 2 comes out, and I have a 3 left over. So my answer is 14. 7 times 2 is 14 root 3 for that nasty problem, that original problem right here. Okay, 14 root 3. It's pretty easy. So sometimes, I mean, you can multiply together. If you would have said 28 times 21, you would have done, I'm just going to do my calculator, 28 times 21, you would have gotten the square root of the 588. And that's okay, but now I got to split 588 up, and that's a lot of work. As opposed to splitting these two guys up, it's a little bit easier. Okay? So that's not really, that's not that bad. So let's do a problem with some variables in it real quickly. And guys, remember when you multiply variables together, if I have like y to the 6th times y to the 7th, remember you add these together. So it's y to the 13th. That's important. So x to the 5th times x. If you get that, make sure you put a 1 there. That's x to the 6th. Okay? That's important. Okay, so let's do one last problem here. Let's do the cube root of, let's do 15 x to the 8th y to the 3rd times the cube root of 10, let's see, we're going to do something different. Let's do 30, sorry. So, is that good? I'm just trying to think if that's a nice number here. Yeah, I'm going to change that to 45 because I just wanted something to work out here kind of nicely. So I'm going to erase this, and I'm going to do times 45 x to the 3rd y to the, let's go to the 5th. Okay? All right, cool. So these are, again, they're both cube roots. That's good. So I can multiply them together. So I'm not going to multiply the numbers together. I'm going to leave those separately. So let's actually, I'm going to write out the whole thing out. So 15 times 45. Let's do the variables together, though. Do you guys agree? Oh, this is to the 5th power. What's going on here? So 8 plus 3 is 11. So x to the 11th And y cubed times y to the 5th is y to the 8th. Everybody okay with that? So this is what you get. I didn't multiply the 15 times 45 together. Too much work. So let's split up the 15. Again, I'm going to write my numbers out here. 2, 3, 5, and 7. Okay, so what's 15? 3 times 5. All right, cool. 45 divided by 3, I get 15 times 3. X to the 11th, y to the 18th. Okay, cool. I can split up 15, so 3 times 5. 15 is 3 times 5 in 3. So now the numbers are all split up because I have all these numbers. Beautiful. Let's do the x's now. Let's deal with the x's. And of course, this is all cube root. So what is 3 goes into what? 3 goes into 9. So x to the 9th, and then y, or x squared, right? So that gives you 11. And y to the 18th. Hey, 18 is perfect because 18 divided by 3 is 6. So I'm going to leave it as y to the 18th. All right, guys, let's do our work. We're looking for perfect cubes. We're looking for 3 of a kind. There we go. There's the three threes. Only 2 5s, so that's not, we can't take anything out there. So that 3 comes out. And I'm going to just draw my cube root here. The 5 stays inside. Okay. 9 divided by 3 is 3. So it's x to the 3rd. And what's left over? That's at x squared. And 18 divided by 3 is 6. And there's nothing left over. So guess what? This is our final answer. Okay? Not difficult. It really isn't. It's just putting it all together and you know, and you guys will be good. But I gave you a ton of examples. I gave you definitely more examples I did in class. I didn't have as much time, but I gave you guys a ton of examples on how to do all these problems. And this is probably one of the more difficult things of the entire chapter. But once you master it, it's easy. Okay? So that's it, math fans. About 37 minutes. So I know it's a little long, but hopefully you guys are good to go. All right? Have an outstanding day, math fans. Adios. Goodbye.